Hi. I wanted to demonstrate a modification that I made to the Stopwatch program, the mini project that we did. And I thought it would be a challenge to, in addition to displaying the time clicking off in a digital stopwatch, to also add a analog stopwatch. So having a clock face with a second hand that sweeps around and clicks at each of the second marks. So let me just demonstrate that first before we start talking about it, so you can see what it is that the thing does. Reset and start. You can see it starting. So you can see the digital clock is down here, showing minutes, seconds, and tenths of seconds. And you can see this guy is right about, should be coming up on 10 seconds right there. Sure enough, it comes up to about 15. And when I hit stop, it'll stop there, and it stops both the hand and the digital. You can start it again, and it continues off where it left off. Reset, and it goes back up to 0, where it can start again. So what I had to do here was, in the code, I needed a function to convert, to draw this line. So the center was easy to find. I drew a circle just with the simple GUI graphics program. This whole thing doesn't use anything really that we haven't learned. It does use a little bit of trigonometry, which you can go out and Google and find out. So it used the couple of math functions, math cosine and math sine. And then it just uses a GUI draw line and a draw circle, which I think we've used too. And then I just did a little loop where I drew the numbers around using the same points that point function that I used. So I wrote a helper function called seconds to point, because we have the time running, so we have that value that keeps changing. We have the center, which I can start one end of the line at, and I needed to find where the end of the line would be for the second hand to position that line each time the count got up to that to another second. So we need to convert degrees to radians. So to determine the degrees, I don't need 360 degrees. I need just 60, because there's 60 seconds in a clock face, and I wanted to tick off 60 seconds. So I took a 360 degree circle and divided it by 60 seconds, and I get 6. So that tells me every 6 degrees on the circle, we should draw a new hand, draw a new line here, which is the clock hand. So I take the tenths of a second and divide that by 10 to give me the seconds, and then do some math here. So let's see the trigonometry right here. I'm going to keep everything else closed, but show you not the tick function, the seconds to pointer is my function here, seconds to point, and I pass it the time right here, which of course is tenths of seconds. So what it does, and I put a little note in here that shows how I got about it. To convert to radians, you take pi times the number of degrees divided by 180, and we'll need radians to convert to points on the circle. So to get my degrees, I need actually every 6 degrees. So I'd take the number that's passed, which is the time running, which is tenths of seconds, divided by 10 to get actual seconds, and multiply that times 6 to get every 6 degrees. So I want every 6 degrees. So that tells me my degrees right here. Then I convert that to radians, and the way you do that is pi times the degrees divided by 180. So I took a math.pi function, multiplied it times my degrees that I just calculated, divided by 180, and that's my radians. Now I need to take that. Now I have, with radians, I can, using the sine and the cosine function, I can come up with the point, the x and y coordinates on that circle. Now I didn't want the hand of the clock to go all the way out to the edge of the clock, because I wanted to show the numbers. So I used something called hand length. And hand length is just the radius, which I set to 90 pixels, and I subtracted 20 off of it, so the hand length would come in a little bit short of the edge of the clock face. So I converted to integer for the y value. For the y value, I take hand length minus the cosine of the radians I just calculated times the hand length again. For the x value, you take the hand length plus the sine of the radians times the hand length. And then what I did is I returned the x and y value. And basically what I did is I added a left offset to the x, which puts it over at the clock from the edge of the canvas, minus the hand length. And then for the y, I added from what I called a top offset, just to bring it down to from the top of the canvas to the clock, minus the hand length. And that's what created it. Then I went in and I returned this, and this is called by the draw function down here. So this draw on the canvas, and it starts drawing this here. So you can see that it stops, reset it, goes back to 0. We can start it again. I also then did a loop in the draw function. That the loop counts off, and it uses the same function, the seconds to point function, and it came up with the location of these numbers. And so I printed in a loop 1 through 12. That's not really something we've talked about, loops, yet, but that's why I'm not showing it here. But that's how I did the numbers across the face. So when it gets up to the top, without waiting another 30 seconds, the seconds will reset and the minutes will increment. And of course you can see that the tenths of seconds are going up to 10 and then incrementing again. So that's it. Thanks very much.